Well, good morning, everyone, and welcome here to the launch pad and our live coverage of the NASA Boeing Crew Flight Test Status News Conference and update. We are waiting for the conference to begin, so stand by. If you have questions, you can send those in the chat by tagging us at the launch pad. We are on the phone bridge, and we may be able to include one of those questions if we get a chance to ask the panel here today. We want to hear from you. When do you think Starliner is coming home? Let us know in the YouTube poll, and if you haven't yet, take a moment, engage that like button, share out the stream, and make sure you subscribe to stay up to date on the latest of Starliner and everything space, because here at the Launchpad, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together. Stand by for the beginning of the NASA Boeing Starliner press update. And if you're just joining us, NASA is beginning their coverage of today's NASA Boeing Starliner mission update, giving us a status update on the testing here on the ground and hopefully the future of what this crewed flight test mission timeline will look like. If you haven't yet, take a moment, engage that like button, share out the stream, and keep sending in those questions in the chat. We're going to get ready to listen into NASA mission control and crews and executives, from NASA and Boeing and the International Space Station as they prepare to give another update on the status of the Starliner crew flight test. Let's listen in.
Good morning, everyone, and thank you for joining us here at NASA's Johnson Space Center in Houston, Texas. I am Leah Cheshire. We're here today to talk about the latest status of NASA's Boeing Crew Flight Test Mission, also known as CFT, and NASA astronauts Butch Wilmore and Sunny Williams. Joining me today to talk about the crew flight test mission are NASA's Steve Stitch, manager of the Commercial Crew Program, and joining remotely, we have Mark Nappy, vice president and program manager of Boeing's Commercial Crew Program. We will start off with some opening remarks from our two participants today before getting into the question and answer portion of the media conference. As a reminder, you can submit your questions by pressing *1, and if you hear your question answered at any time, you can press *2 to remove it. So we will start off with those opening remarks, and I will turn it over to you, Steve.
Yeah. Thanks, Leah, and thanks for everybody to join in today, and we'll give you a status of where we're at relative to the crewed flight test mission. Last time we talked was about 2 weeks ago, so a lot has transpired in those 2 weeks, and I thought we would sit down and talk a little bit about all the work that's happened across the country relative to what's going on. We don't have a major announcement today relative to a return date. We're making great progress, but we're just not quite ready to do that. We're here to be open and transparent and talk about, all the great learning that's happened. So let's start with the thruster testing. As we talked last time, a couple weeks ago, we embarked upon a test campaign at the White Sands test facility to test one of these RCS thrusters. This was a thruster that was slated for a future flight. The thruster itself is pretty small. It's about 2 pounds. I could hold it in my hand. The flange we talk about would sit right in the palm of my hand. So it's a very small thruster that produces about 85 pounds of thrust. What we endeavored to do at White Sands is to take that thruster through the profile that it saw during flight in terms of replicating the firings for the uphill phase, including the docking day where some of these thrusters failed off, and then replicate the downhill phase. The thruster went through 2 uphill phases. So we started with the launch campaign, put it through all the pulses that it saw up through docking day, and then we backed up and put it through another docking day. We've been endeavoring to get the temperatures up. Remember, we talked about this theory that the oxidizer would vaporize in the thruster, and that would reduce the combustion in the thruster and reduce the thrust. And so we needed to get the temps up to flight, so we had to put in some extra pulses for that second run. And then we ran a total of 5 different downhill profiles. And the very last one was important because the last one, when we saw some degradation in the thruster, we were able to replicate the downhill phase, which the most of the thruster firings for the return are really at the deorbit burn. So we did that as well. So this thruster has seen quite a bit of pulses, maybe even way more than what we would anticipate we would see during a flight, and more aggressive in terms of 2 uphills and then 5 downhills. What we did see in the thruster is the same kind of thrust degradation that we're seeing on orbit in a number of the thrusters. We're seeing reduced thrust, which is important, and Mark will talk a little bit more about that. Right now, we're in the middle of the teardown of the thruster. So we have the thruster at the White Sands test facility. It's in the lab. It's been disassembled. And we're looking very carefully at the fuel, on the fuel valve and the oxidizer valve. There's 2 valves that open and close as the thruster is commanded to allow propellant to enter into the combustion chamber, the injector, and then have combustion. And on the oxide, Mark will talk more about it, but we're seeing a little bit of a bulge in the Teflon seal, which can restrict the flow, and that's matching very closely to what we're seeing in flight. The team is also looking at that thruster to see could that particular seal survive the rest of the flight, and that's the important part. Now, of course, if you look at what we did on that thruster, it shows that we can survive up to 5 downhill legs. And so we're making sure that that seal stays intact, and that's the important part of what's going on with the thruster today. Let's see, we made one decision relative to the downhill phase of the flight. We had, this is not part of our flight test objectives, but part of some additional learning we wanted to do. We had what's called an operational checkout maneuver where we were going to use the backup mode a little bit. We realize now that some of the manual maneuvering puts some extra stress on the thrusters, and so we're not going to do that manual flying between undock and the deorbit burn. We're going to eliminate that for this flight. The other thing that we've been doing the last couple of weeks is trying to understand the helium leaks. As you know, while we're docked today, we're not leaking any helium. The manifolds are all closed, and so that system is isolated. We have done a lot of testing on what we call Service Module 2. Now, this was a service module which was planned to be launched on OFT2 back in the summer of 2021. It's sat at White Sands for about 3 years, and it's been loaded with propellant vapors for 3 years. And so what we've been doing is disassembling some of the flanges, and we're seeing some of the seals experience some severe degradation from the NTO vapor. Now, the difference between that test article and the flight is we've been exposed for about 3 months on flight, and now this test article has been wetted and has oxidized for about 3 years. So that flight rationale for the helium system came to the Starliner mission management team on, it was July 11th, and everybody was go to proceed with the rationale for the helium leak. So we have most of that work behind us. We're now understanding a little bit more about this oxidizer permeation phenomenon that can cause some degradation of the seals. And the next thing we're going to go do is, and we know the margins for the rest of the flight, the next thing we want to go do is a docked hot fire test. And that should happen this weekend. So at ISS, what we're going to do is we're going to fire 27 of the thrusters. We're not going to fire the one aft thruster on the bottom doghouse. It's called B1A3. That's the one that has really low thrust. So we're going to fire all those thrusters through a number of pulses just to make sure before we undock that whole system performs the way we expected and the way it did last time we checked it. We'll also get a chance to look at the helium system. It's been 6 weeks since we last checked that helium system. That was on June 15th. So we'll pressurize manifold by manifold and then hot fire the thrusters, and then we'll get a chance to look at the helium leak rates and verify that the system is stable. So it's a very important set of tests over the weekend that we'll do. We've had a lot of learning. I would say this mission has been great to prepare us for future long-duration docked increments. Some of the things that we've learned, is the ability to power up Starliner when we need it. We powered it up multiple times to test various things on the vehicle. The crew has practiced many things, data and video transfers. They exercised charging of the battery systems inside the cabin, things that you do at home with things that need recharged. They've done some practice of manual flying for entry, which is a backup capability on the tablet. We've actually filled the sublimator tank, which is a water tank used for cooling for entry. We've had multiple mission management team meetings. We've been able to, in the commercial crew program, do mission management team meetings for Starliner and Dragon at the same time, which is something we'll need for the handovers in the future. There's just been a ton of learning over the last couple of months while we've been docked that really is preparing us for increment operations. More learning will happen with the docked hot fire, which we hadn't planned, what you're going to do, and that'll be probably part of every increment mission leading forward. So we're methodically working through the data. We have extended the battery waiver. We talked about that. We had 45 days before. We've now doubled that time to 90 days, and so that's been approved and through the system. So that gives us life, if we need it, all the way out through, let's say, the early September timeframe. We'll work to execute an agency review as soon as we're ready to do that. That could be as early as late next week. We are following the data, and we'll schedule that review when we need to. And then after that, we'll set the undock time. As I've said before, the key attributes of the flight rationale really are that we understand the helium leaks, we understand the stability of the leaks and how we could manage those should they get bigger. We have a criteria in place that we have established, a leak rate that we'll check before undock and verify that system is good to go. The hot fire test this weekend will give us confidence in all the thrusters. And then now we're having the understanding coming out of White Sands relative to what that testing means and how it applies to the rest of the thruster system. And then really it's about the key use of the thrusters for the deorbit burn are for the deorbit burn. That's the next time we use them. We know the thermal environment is less for the deorbit burn. We know the stressing cases on the thrusters are less. And so we're looking at that and understanding the redundancy required for the deorbit burn. And that's really, I think, the final pieces of the flight rationale that we need to put together. The team is doing great. The joint Boeing and NASA team is doing well. They're working side by side with each other every day. We're methodically working through the data, and we'll come home when we're ready. And I'll hand it over to Mark.
All right, thanks, Steve. Good morning, and thanks, everyone, for joining us. I'll give you a little bit of a recap of what we have been doing and, of course, what we have planned to do here over the last several weeks. Last time we talked to you, we had 33 actions to complete in order to get to a place where we thought we had a good vehicle to come home and we could learn something about the root cause. Of course, the long pull to those actions was all the testing at White Sands that Steve talked about. At the time, we believed we had thrusters that were healthy, and we concluded we were good for emergency return. But remember, we said we did not have root cause and know what it was going to take to fix it permanently. So we said, let's take the time. Let's figure this out. Let's run this testing at White Sands. If there's anything more we can do after that testing, while we're docked to ISS, let's take advantage of that, and then we'll come home. So I think the plan has played out really well. In addition, it's given us additional confidence to undock and return, and we have a little bit more work to do, as Steve has outlined, and I'll go through some of that as well. The White Sands test results, first of all, let's start with the helium system. We have a service module at White Sands that was exposed to propellant, and it's been exposed for about 3 years. So it was a really good test case to go and do some leak checks on and then take that hardware apart. We did those leak checks. We found leaks, of course. It's been exposed to NTO for quite a while. We took the hardware apart, and we found pretty good degradation of the steels, which indicated that they had been exposed to NTO and degraded. So that was a really, really good data point, both from the standpoint of finding out that it had degraded seals, but also we could capture a leak rate, which could end up being our worst case kind of leak rate because this hardware was exposed for so long. On the second part of the testing, of course, was the thruster testing, and Steve outlined that testing, but it was very stressful testing of that thruster through ATP, uphill and approach and docking, some increased temperature profiles, and some very stressful downhill runs. So all of that was done with the thruster very heavily instrumented, which gave us a lot of information. From that information, and of course from the inspections after the test, we've determined two things. One is that there's some Teflon from a seal where the NTO enters the thruster, and that seal was eroded. And when we looked downstream from that seal, we found that material was lodged in a downstream filter. That is where the NTO goes through. So obviously that restricts flow of NTO and may be part of the cause of the degradation that we've seen in flight. The bigger finding was where the NTO goes through a port to where it gets to the injector inside the thruster, and there's a poppet that opens and closes and allows that NTO to go through. At the end of that poppet, very small poppet, it's similar to the small inflation valve that you have on a car tire or a bike tire. That poppet has a Teflon seal at the end of it. Through the heating and the natural vacuum that occurs with the thruster firing, that poppet seal was deformed and actually bulged out a little bit. And again, it was an indication that that's restricting the NTO from going through the system. So again, a really good finding. When we looked at the information, we looked at the data, it really does replicate well what we're seeing in flight. So we think these findings are very significant and are likely the root cause. Obviously, knowing root cause is what gets us to permanent fixes. So there's very strong evidence, and we're going to continue to take that hardware apart so that we can finally prove this. Today we're performing the final hardware inspections, and we're doing some flow analysis through that type of valve arrangement where we have Teflon in the seal, Teflon in the filter, and this bulging of the Teflon at the end of the poppet. And we'd like to see if we can model this restriction of NTO and recreate what we're seeing in flight. With all these test results, we determined that we could run one more set of tests while we're docked, and it's really icing on the cake for us. So Steve talked about the one more docked hot fire test. That's going to verify all the thrusters are acceptable at the acceptable performance levels. Again, we learned something from this flight. We didn't know that other visiting vehicles do this before they leave, and so we're probably going to make that part of our normal regime when we are doing long-duration missions. Also, we're going to do the helium manifold leak checks. Again, that'll give us some data points on how stable the leaks are and assure there's no additional NTO degradation. Lastly, we have a very valuable guidance, navigation, and control integrated performance model that was incorporating failures to answer the question, what if we're wrong on some of these? And so they ran over 300 cases, And of all those cases, the results were either green, that we could return home safely, or were determined to be not credible, or they had operational controls that could be applied to make sure that we returned home safely. So what's next? We're going to share the data and flight rationale with the mission management team. We have one more meeting tomorrow to do that. We'll use the weekend if required. We're going to perform these docking tests that we've described, and then, of course, there'll be more reviews. We'll bring the complete story to the agency for the undock review sometime next week, like Steve has outlined, and then we'll be ready to execute the last part of the mission. The last several weeks have been really helpful to understand the helium and thruster anomalies and how to address these problems for future flights. That's been the real goal here, is to be able to address future flights and to gain the confidence that we needed for this mission. We need to take the time to get the community all this information and get back to completing the CFT mission. So, our mission was to get the crew to ISS. That's been completed. Our mission was to learn from a flight test. A lot of the learning that we've achieved so far really, in my opinion, could only be achieved through the flight test. And now it's time to get on with returning the crew safely, and there's that step left to go. So appreciate your time this morning, and back over to you, Leah.
Thank you, Mark, and thank you, Steve. We'll now get into the question and answer portion of our session today. A reminder, you can press star 1 to ask a question by raising your hand, or press star 2 to lower your hand if you hear your question has been asked. Please limit yourself to one question at a time. We already do have quite a lot of folks in the queue and want to make sure we can get through as many as possible. And don't forget to state your name and affiliation and to whom your question is addressed. So we'll start right here in the room.
Good morning, Steve. Good morning, Mark. I'm Mark Strassman, CBS News. Wilmer and Williams went up originally when they launched on June 5th with the goal of staying up for about a week. They've been up there for more than 7 weeks, 50 days today. Given where we are in the process, can you definitively say that they are going to come back on Starliner? And if you had to do it differently, how would you do it?
Yeah, I'll take the question and see if Mark has anything to add. Yeah, our focus today, as Mark said, as Mark and I have been working for the last number of weeks, is to return Butch and Sonny on Starliner. I think we're starting to close in on those final pieces of the flight rationale to make sure that we can come home safely. And that's our primary focus right now. We have contingency options. We've put those in play. NASA always has contingency options. We know a little bit of what those are, and we haven't worked on them a whole bunch, but we kind of know what those are. But right now, we're really focused on bringing Butch and Sonny home on Starliner.
All right, our next question comes from the phone. That is, I'm sorry, Mark, were you going to offer some more words? Sorry about that.
I think the only thing that we do differently, Steve and I have talked about this, would not have been so emphatic about an 8-day mission. We kept saying 8-day minimum mission. I think we all knew that it was going to go longer than that. We didn't spend a lot of time talking about how much longer, but I think it's my regret that we didn't just say we're going to stay up there until we get everything done that we want to go do.
All right, thank you both. Now we'll go over to the phone bridge. Our next question is from Anthony Leone with Spectrum News.
Hello, gentlemen. Thank you so much for taking the time to answer our questions today. I know that your goal is to return Butch and Sonny on Starliner, but I know you guys love having backup plans. What happens if you're looking at all these test results and it determines, it's too much of a risk? What is the backup plan in returning them if it's not on Starliner?
Yeah, I mean, obviously the luxury in our program today, and we've never really had this option in other NASA programs, is we have two different systems that we're flying. Obviously, the backup option is to use a different system. I would rather not go into all those details until we get to that time, if we ever get to that time, on what we plan to do. But the beauty of having Dragon and Starliner and two different diverse space transportation systems is we can kind of use those as backups. Someday Starliner could be a backup to to a Dragon mission. And we've looked at all kinds of different contingencies for that. You've seen the Russians send up an empty Soyuz, right, to return a crew when they had a coolant leak. So I think the beauty of what we have in Commercial Crew is two different systems. And we would employ those systems if we need to. But we really have our team focused on, as we close in on this final flight rationale, returning Butch and Sunny on Starliner.
All right, thank you. Our next question is from Will Robinson-Smith with Spaceflight Now.
Yes, hi. Thanks so much for taking time to speak with us today. Question to Steve Stich. Following up on something that we talked about 2 weeks ago, as far as the timing of everything with Crew 8 coming back or not going up. Given it sounds like there's more work to be done with Starliner on station, has the timing changed or the thought of having a direct handover between Crew 9 and Crew 8 been adjusted? Or is that still the plan, or do you think that Crew 8 may need to come back before Crew 9 goes up? Thanks.
Yeah, we're going to meet, Dana Weigel and myself are going to meet this afternoon and look at all the different options. Right now we think we can continue to do this direct handover and let Starliner have undock opportunities through probably August 19th, 20th. We can adjust we've got a pretty good window. We'll talk about that tomorrow for Crew 9. We could adjust the handover a little bit to the right and not interfere. There's a key Soyuz handover coming up in September around the 11th through the 23rd. And that's really the time frame we want to have both the handover for Crew 9 and Crew 8 completed by that time frame.
Okay, our next question is from Kristen Fisher with CNN.
Hi there. Thank you all so much for this update. Really appreciate it. I would just like to ask one more time about the very first question from Mark over at CBS. And, his question was, can you definitively say that Butch and Sunny will return on this Starliner spacecraft? And the answer I interpreted and got was that at this point you cannot say definitively that they will return on this spacecraft. Just want to make sure I have that right and give you both a chance to respond and clear that up just one more time. Steve.
Yeah, our prime option, right, is to complete the mission. There is a lot of good reasons to complete this mission and bring Butch and Sunny home on Starliner. Starliner was designed as a spacecraft to have the crew in the cockpit. The crew is integral to the spacecraft, and we've seen how Butch and Sunny really helped the ground team out on the docking day with some manual flying and recovering thrusters. And the vehicle is really set up to work with the crew. So we really, our prime intent is to return with Butch and Sunny. We need to get through the process, right? We have another critical Starliner mission management team to review all the thruster data that we just talked about. Mark and I are probably a little ahead of announcing some of these results today. We wanted to be transparent with you. That has to happen, and then we have to go through an agency return review. And if those gates are successful, then the prime option is to bring Butch and Sunny home on Starliner. That's what we've been working on. We really want to get the rest of the flight test objectives. There's a lot of objectives for the flight. Having Butch and Sunny on board during the deorbit burn and during the entry, understanding how they monitor the system, how they work with the suit interface for landing, getting suited up in the vehicle, and then there's a whole process of landing and recovery team that we really want to demonstrate before we get into the Starliner 1 mission where we need to do it with 4 crews. So this is part of the certification. It's part of finishing the mission. That's really what we want to do, and I'll turn it over to Mark and see if there's any additional questions.
Our job, my job, is to provide a safe vehicle for return of the crew. And, we're, like Steve said, we're ahead of the game here because we've had a chance to look at all the information. And, of course, I'm very confident we have a good vehicle to bring the crew back with. We have to take the next steps to show that information to everybody else, and that leads up to the agency review. And that's what we're going to do over the next week.
Okay, thank you. Next question is from Marcia Dunn with the Associated Press.
Oh, hi. Steve, question for you. What is the earliest you could envision Starliner and crew returning? At this point, it sounds like no earlier than mid-August, but you tell me. And what would be the outside envelope on that estimate of coming back? Thanks.
Boy, I hate to pick a date. I mean, I think, if we have an agency review next week and that review is successful and everybody polls go to proceed, I mean, it's a little bit of time after that, right? So depending on what's going on at ISS, it's kind of a busy time at ISS. If you just look at the next few weeks, there's a Northrop Grumman a resupply flight that the space station program needs to transpire. The launch right now is around early August, so we just need to sort of sort some of that out, and then we can work on when Starliner returns. And then on the long side, I mean, we can work our way through August and then move Crew 8 or Crew 9 a little bit, and then maybe even look at a indirect handover option. So.
Our next question is Elizabeth Howell with Space.com.
Hi, everybody. Thanks for taking your time. I'm looking for a little bit of engineering clarity. This might be for Steve. So Aerojet Rocketdyne is a longtime supplier of thrusters, and I'm just trying to figure out what the relation is between the thruster system, the propulsion system, and some of the issues that have now been uncovered in the ground testing that both you and Mark were talking about, just in terms of would there be some kind of design changes, some design conversation between the two, any sort of discussion about the flight heritage, whether this has happened before? That's kind of the direction I'm thinking of. Thanks.
Yeah, I'll start and then I'll let Mark add to it. I think what we're seeing is that this thruster has heritage from Aerojet Rocketdyne and other programs. It was modified for Starliner for its purposes on the service module. I think what we are now starting to understand much better on this mission, and we would not have understood this by just staying on the ground and doing more analysis and tests, is we understand now much better of the integrated effects between how the guidance navigation control system, the flight control system during rendezvous is commanding the thrusters to fire, and then what the result of those thruster firings are with the thrusters being in these doghouses. The doghouse has a lot of insulation on it. It's designed to protect the thrusters from cold temperatures while we're docked. But I think we're now seeing an integrated effect that we maybe didn't uncover on the ground during some of the early testing with Starliner, that if you command too many pulses on a thruster and have those thrusters pointed at the sun, like we did for the 8 hours that the crew was asleep, and have some OMAC firings, that we can have some crosstalk in the thermal and have the temperatures increase. And so that's where we see the thrusters degradation that Mark talked about and what we're seeing in the testing. So we understand that a lot better. I think for the next flight now, it's a matter of is there thruster modifications required, or can you go do, or the thermal in the doghouse, or can you go just modify the way you're flying and fire the thrusters less? I would comment that in my experience, the Starliner has some really tight, precise deadband limits on the way it flies, and perhaps there's a way to relax some of those in various phases, so not to put such demand on the thruster. And I'll see if Mark has anything to add.
Yeah, so Aerojet Rocketdyne is our propulsion supplier for the doghouses. They have been working with us since day one on this and have been just a fantastic partner in trying to get through these tests, understand what the problems are, understand what we've done in the past, and then start building the list of things that we can do in the future. Like Steve said, there's two problems here. There's the helium leak, and there's the thruster and how they're performing with the heat loads that they're seeing. So there's things that we can go do with both of those, and we've already started that menu of items on what it is that we want to go finally implement. Do we need a new seal for the helium? We've already put some on order, and we're doing quite a bit of testing along with AR to understand what best type of seal we should be using. On the thrusters, we have, a menu of items. Do we adjust the profile that we fly to? Do we put some different thermal protection inside the doghouse? There's a lot of different options. And again, Aerojet Rocketdyne has been fantastic in working with us, and and then even getting some of their sub-tier suppliers to come in and help with the troubleshooting and the final resolution.
Our next question is from Stephen Clark with Ars Technica.
Hi, thanks for doing this. I think my question, if I understood earlier in the introductory comments from Mark, you didn't do this type of full profile testing on the thrusters, to fully replicate an uphill and downhill run on Starliner on the ground. Correct me if I misunderstood, but if you didn't do that, why not do that during development to make sure it could withstand all of these the stresses that it undergoes in flight? And just briefly, the hot fire test this weekend, what day is that going to be scheduled, and will the crew be involved in that, or will it be fully ground commanded? Thanks.
I'll start with the first question. So when we would design and build, and the way we verify our design, we verify our design through two methods. We either test, or we have integrated models that try to predict what the conditions are going to be, or we do both. And some things you cannot test. So when we talk about the thruster getting hot, it sounds like it's just one thruster that was subject to heat from itself. But there's 7 thrusters inside the doghouse, and that doghouse acts almost like a thermos. And so it's likely that the heat is not just coming from the one thruster, but it's coming from the thermos effect of that entire doghouse. That was modeled. And I think we're learning more about the actual flight conditions that we'll have to go back and adjust that model. Again, this is the type of learning that you get in a test flight, and you really can't simulate it until you get to flight. And Steve, if you want to talk about the latest on the testing.
Yeah, could you repeat the second question? I apologize, I didn't quite catch the second part.
I don't think he's in the speaker view anymore.
Oh,
Sure, Steve, can you hear me?
yeah, go ahead.
What day do you plan to do the thruster hot fire on ISS or on Starliner this weekend, and will the crew be involved in that, or is it entirely ground commanded? Thank you.
Let's see, we're looking at either Saturday or Sunday as the timeline becomes available. A lot of the pulses are ground commanded, but knowing Butch and Sonny, they'll be in the vehicle, they'll be listening and watching and following along with all the testing. So I don't have the specific date or time, but it's either Saturday or Sunday.
All right, next question comes from Jim Siegel with Florida Media Now.
Hi, everybody. Thank you for taking my question. I wanted to follow up a little bit on one of the other questions that was asked. First of all, it sounds like you've done a whole lot of very thorough testing during the time that the Starliner has been up at the ISS. And I'm curious about how different is that testing from the testing that was done during the development phase of and the pre-flight phase of this process. Thank you.
Yeah, I can start, Mark. I was probably around a little bit during that time frame. Typical thruster testing is done such that you pick what you think your worst case, I would call them duty cycles. So duty cycle is thrusters on, thrusters off, then the next time it's commanded on and off. And the timing between each of those, the length of how long it's on and then the period it's off before the next time it's commanded on is super important. And those were picked to during qualification to try to envelope the most stressful cases. I think the part that Mark talked very well about that was maybe not modeled as well is this integrated effect from how the GNC system was going to command it during the stressful parts of flight, which are like the approach to station. And then the second part is this effect of the thrusters being in this doghouse. I think of them almost like when you get pizza delivered to your house or your apartment or your condo that comes in a little container, right, that's got aluminum foil on the outside to keep it nice and warm. The doghouse itself almost is acting like the little pizza oven that the pizza delivery man brings to you. Anytime there's heat, every time a thruster fires, there's combustion, and heat is released and it goes back into the doghouse, and it kind of is kept in that doghouse. And so, as Mark said, an OMAC engine, an orbital maneuvering engine, can fire and have crosstalk over to the RCS thrusters. And we know that we point the tail to the sun, essentially that aft part of the service module, to put the solar rays to the sun for a long time before we go dock. And we see the aft thrusters, fail more because they're commanded more during the rendezvous profile. And also they start at about a 50-degree Fahrenheit warmer temperature because they've been pointed at the sun. So those are the kind of things that weren't totally caught in, I would say, the qualification and the analysis that we did. And I would say we probably couldn't have learned that on the ground. We needed to get into flight to find it, and we did. And so now we know what to go fix for Starliner 1.
Next up, we have Chris Davenport with The Washington Post.
Hey, thanks very much. You had mentioned the NTO leaking through the Teflon seals earlier, but wasn't that the problem in 2021 when it mixed with that humid Florida air and caused the corrosion on the valves? Just checking my memory on that. But if that's right, was that not addressed, given that it sounds like you're dealing with maybe a somewhat similar issue? I'm just curious how much of this data you're sharing with Butch and Sunny and what their morale is like, considering that there's no return date as of yet. Thanks.
I can address the first part of the question. It was a different phenomenon that we were dealing with back in 2021. That was on what's called a orbital maneuvering system, reaction control system jet isolation valve, and that was a corrosion issue with the moisture from the Florida air mixing with vapor. What we're seeing here in this thruster that Mark talked about, the Teflon is essentially bubbling a little bit, and so as that thruster poppet comes in and seats down, if you think about it, when it pulls back, the area that is available for propellant to flow in is less, and that's why there's less oxidizer flowing through that thruster valve into the injector, which means less thrust. So it's a little bit of a different problem. It's a problem of the heating inside this thruster valve versus the other was a propellant flow valve that regulates the flow into the manifold. So it was a little different scenario. We didn't necessarily understand the temperatures could vaporize the propellant on the oxide and then cause this Teflon to bubble a little bit. So related to oxidizer, but a totally different problem. And was there a second question that I missed, maybe? Morale. Oh, morale. Mark, I don't know. You guys talked to the crew recently. So.
Yeah, our mission ops team and our engineering have been talking to the crew, keeping them up to speed with what we've been finding in all these tests and what our plans are to do any testing, any additional testing, or potentially what the additional work might be after undocking. And the crew is very understanding and is absorbing all this information and seems to be in good spirits.
And I will add, they seem to be enjoying their time on station. When you watch them, they're eager to do experiments for station, eager to help out, eager to do maintenance when required. They've both been long-duration crew members before. When our team talked to Butch and Sunny the other day, they said they were in really good spirits. And we're kind of having a good time. So,
thank you both. Next up, we have Michael Sheets with CNBC.
Do you want to walk through quickly this timeline between now and the agency review that you say needed before you set a return date in stone? So, as far as what next steps and what needs to be, what boxes need to be ticked before then, could you just walk through, what specific milestones we need to see? Because the one thing that's not clear right now, after you guys seem to understand quite a bit about what has happened with the thrusters, is all of the detailed milestones between here and that review. So walking through that would be really helpful on that timeline.
Yeah, I can start, Steve, and then hand it over to you. Because it is twofold. I've got to complete work so that we can turn it over to Steve, and then NASA does some work as well. So today we have the poppet that I talked about earlier being dissected so that we can look at one last area and make sure that the seal that we talked about that has the little bulge on it is going to stay intact. We expect to get that done today. This afternoon, we're going to talk about the hot fire testing that we want to do this weekend. That's going to be done in a mission management team. Tomorrow, we will bring what we call part 2 of our flight rationale for the RCS thrusters. Yesterday, we did part 1. It's a very large package. So tomorrow, we'll do part 2, and that will complete all the information being presented to NASA and to our mission management team on everything that we know about the testing, what we believe the root cause is, what we believe our flight rationale is, what we know that our operational workarounds are, our operational controls are. All that information, we expect that to take several hours to get through, and then we'll conduct that testing, that set of testing this weekend with the hot fire test and the manifold leak checks. And so that will really wrap up all the data that we need. Then it becomes sharing of that information in an incremental fashion so we can get to the agency review. And a lot of that is what Steve's going to have to do. So over to you, Steve.
Yeah, I think Mark said it very well. I mean, that's the thruster teardown, bringing that to the MMT that he talked about, this hot fire at ISS to make sure the helium system first is working the way we think it is and the leaks haven't changed, and then all the thrusters are firing. And then we want to do what we call an integrated assessment of all the data, and that will happen after the weekend, Monday or Tuesday. And then really there's some significant education of the leadership heading into this agency flight readiness review. I would say, and you've pointed out that we've struggled to explain all of what's going on, and I apologize for that. This is a very complicated subject with the helium leaks, combined with the thrusters, combined with how the GNC flight control system will work during the deorbit burn. Getting everybody educated and understanding that ahead of the flight readiness review is the next step that we have on our side after we have the mission management team meetings that Mark outlined.
All right, our next question is from Joy Roulette with Reuters.
Having the astronauts return on Starliner required for Starliner certification? And also, to get back to an earlier question, you said the 2021 moisture problem was a bit different than the problems that we're seeing today. But when the teams were closely analyzing those propulsion system issues in 2021, was there any kind of likelihood that popped up of these new issues? Was there any kind of hint that this might occur in another scenario? And did you wish Boeing and Aerojet at the time just agreed to redesign the prop system? Thanks.
Yeah, let me try one more time, and maybe Mark can help me. So the problem again in 2021 was not related to firing a thruster at all. This was related to how the oxidizer vapor reacts with moisture to corrode a valve that didn't maybe have the perfect material choices inside the ox isolation valve and the thruster valve. Boeing and NASA agreed to put in a very strong purge system to mitigate that problem. That purge system is in place. And then we went and flew OFT-2. I would say maybe there were some clues on OFT-2 that maybe this problem existed. We had some thrusters fail off in that flight. We thought we had fixed that with some software changes and some integrated propulsion controller changes. I think it really wasn't until this flight, this set of rendezvous trajectory, this set of approach, that we stressed the thrusters. And this isn't a corrosion problem in the thruster. This is a problem where as you get heat into the thruster at certain pressures, that vapor, the oxidizer will vaporize and become a gas. And it becomes very hot, and it causes this seal to swell. And that's a different problem than what we had in 2021. And so we didn't see any likelihood of this happening at all in 2021. So there was no know we should have done a major redesign of the hardware because we didn't know this problem existed in 2021. And I'll see if Mark has anything to add.
Yeah, I'll try to explain it a little. Steve does a nice job, but I'll try to explain it a little bit differently. We've got two problems. One is the thruster degradation or the thruster susceptibility to heat. That is completely different, night and day, from the problem that we had with the oxidizer and the corrosion several years back. 100% different. The helium problem is associated with natural permeability of a steel where NTO is naturally permeates the steel, completely expected, but it was probably more than expected because it may be degrading the helium seal that's in there. So the natural fix to that is to just change that seal out to a material that's not so susceptible to NTO. So the thruster problem is completely different, not associated whatsoever. You cannot compare the two. The permeability of the NTO through the Teflon seal of the port where the NTO goes through, it's expected that there's some ability for NTO to get through there, and we just need to go change the seal to something that's not as susceptible.
Our next question comes from Micah Maidenberg with the Wall Street Journal.
Hey, appreciate it, Leah. Steve and Mark, my question is about the 5x5 risk assessment tool that NASA uses. Has the agency and company filled out those scorecards regarding the thrusters and the leak issues? And if so, what were the results from each side, and how would you explain any differences in the scores, if there are indeed any? Thanks.
Yeah, I would say that's a bit of our next step, right? We've tried not to get to that step. This, when we call this integrated assessment, integrated risk assessment, is the next step for NASA to then try to put all this together and understand the overall risk. And we haven't really done that. We've done some preliminary work on the helium system. I would say that was had various scores. Now that we have more learning from the Service Module 2, degradation to the NTO vapor, I think we need to rescore everything. So that's the next step that we need to do after we complete the hot-fired ISS, the thruster teardown, and bring that to the Starliner mission management team. And I'll see if Mark has anything to add.
Yeah, I agree. That is the next step. But I did talk about something in my opening remarks that is really valuable to contribute to that risk assessment. When I talked about the guidance, navigation, and control integrated performance model, we have a very good accredited model that predicts what the profiles look like, what all of the attributes are when you do a return. And so that model has been run. And again, all of the scenarios, over 300 scenarios that were run, either turned out to be green, either turned out to be not credible, or there were operational controls in place to protect against something going wrong. So that's a really, really valuable piece of information to have going into this risk assessment.
Our next question is from Marina Koren with The Atlantic.
Hi, a question for both of you. If we characterize the thruster and helium anomalies as large to medium-sized problems, are there any issues that you've seen or that Butch and Sunny have reported that you'd place in a category of small-sized problems, and maybe you haven't addressed those with us yet because these bigger concerns are obviously your primary focus right now? Thanks.
Our team goes through everything, and we call them funnies or actions that need to be addressed. And our team goes through those every day. We go through them at the mission management team. There have been a number of them, but they're really small and nothing that we consider anywhere near the magnitude of the two anomalies that we've mostly talked to you about. So, it's a shame that these two have gotten all the attention because the vehicle has really performed extremely well, and so the value of the mission was to learn stuff like we've been learning and to be able to, understand it and then fix it once and for all.
Yeah, and I would add, I mean, there's always in every flight, even all the way back to shuttle, a number of funnies or things that we got to go work on. I mean, some of the ones that come to mind that we've worked through, sensor issues. The sensor looks a little erratic, working through that. On some of the buttons on some of the displays, there's a little bit of a rubbing off of some rubber. On one of the comm caps, one of the crew members, a grommet maybe missing on a comm cap strap, those sorts of things, which happens every flight that you fly. There's those sorts of things that we have to go work through. And the Boeing team does a great job of tracking every single one, bringing it to the MMT, and then talking about, post-flight, how they're going to go correct those things. So there are a number of them, but the two, as Mark said, that we've probably talked the most about really are the helium leaks and the thruster fail-offs.
Next up, we have Mark Carreau with Aviation Week and Space Technology.
Thank you. Mark Carreau, Aviation Week and Space Technology. I believe this is for Steve. Can you sort of describe the robustness of the agency return review in terms of, participants within, not by name necessarily, but just, the different elements of NASA that would participate in that, and if there's any sort of outside participation that would be included for sort of independent assessment?
Yeah, good question, Mark. So, yeah, the agency FRR will be chaired by Ken Bowersox, the Associate Administrator for the Space Ops Mission Directorate. We'll have participation from the various center directors, Johnson, Kennedy, Marshall, from the Human Spaceflight Centers. We'll have participation from the Office of Chief Engineer, Safety and Mission Assurance, the Flight Ops Directorate, and Health and Medical will be there. Just our standard board that we would have for any flight readiness review. Obviously, the program will be there as well, along with our chief engineers, chief safety officers. The crew office will be represented, obviously. We will invite the Aerospace Safety Advisory Panel to the review. I know they have a 3-day review going on around the same time frame. So, but that will be the one outside. They're not really a voting member of it, but they will listen to participate and kind of understand where we're at, so they can understand our process. They sat in on the 2 flight readiness reviews prior to launch as well. The first one that we had back in April, and then the Delta review in May.
Our next question comes from Bill Harwood with CBS News.
Yeah, hi, thanks. I think this is for, well, maybe for both of you. Can you refresh my memory about what we know about the health of the OMAX thrusters, and maybe talk a little bit about how these smaller thrusters you're talking about play into the deorbit burn? And I guess what I'm really looking at is what sort of actual worst-case failure would it take to strand the crew in space after undocking? In other words, what is the worst case that you're protecting against, and how remote are the odds of something like that based on what you know today, if that makes sense?
Yeah, let's see. Let me try to adjust. I think they had 3 parts of it. First question is related to the OMAC engines. And so we have, those are about 1,500 pounds of thrust. We have a total of 12 OMACs that fire in the direction for the deorbit burn. There's 3 of them in each of the doghouses, each of the 4 doghouses. We've fired every single one of those thrusters. We probably have, I hate to quote a number, 200 seconds of runtime total. Those thrusters have performed nominally the whole flight. In fact, we reviewed that data just yesterday at the Starliner Mission Management team to remind the team that the thrusters have performed very well. So the primary means of the deorbit burn is the OMAC thrusters, one of those thrusters in each of the 4 doghouses. When you get into what the purpose of the RCS jets are, obviously they are used from when we undock, they're used for the separation maneuver from ISS. And then we back away and we go down underneath the space station. And those are used for attitude control for that and those small burns. And then the biggest stress is when we fire the OMAX, the 4 OMAX for the deorbit burn, the RCS thrusters are there to hold the attitude. The space shuttle had orbital maneuvering system engines, which gimbaled and moved to control the attitude. Starliner fires those thrusters to get the deorbit delta V we need, and those are it's about a 66-second burn. And the RCS jets are used to hold the attitude. And then after that, there's a maneuver out of plane, and the service module and the crew module separate. And the service module does a backaway maneuver, and then it does a disposal maneuver with those thrusters. And after that, the crew module continues on with a different set of thrusters that will be used for the entry. The worst case scenarios are, multiple large helium leaks that we think are very unlikely based on what we're seeing. That's a scenario that would be a worst case scenario. After we check, we're going to do a check this weekend on the helium leak scenario, and then right before undock, we'll repressurize the system and check the helium leaks and make sure that we have a criteria established and a leak rate we know we shouldn't exceed, and we have that number defined already. And then it would be some diabolical case of some thruster failures that would be some worst case. And so we're making sure all that's covered, Bill, and that's kind of what we're going through right now at the very final phase. And I'll see if Mark has anything to add.
I think you covered it well, Steve. Thanks.
All right. Thank you both, Mark and Steve, for your time today, as well as everyone who joined and answered questions. Unfortunately, we only had an hour for today's news conference. However, you can join in to learn more about the Commercial Crew Program and our next flight, which will be NASA's SpaceX Crew 9 mission to the International Space Station. Tomorrow at 12 p.m. Eastern Time, we will have our mission overview news conference, followed by a crew news conference at 2 p.m. Thank you again, and we will see you soon.
It's a new era of pioneers, star sailors, thinkers, and adventurers.
3, 2, 1, 0. All engine running.
Let's go.